Okay, we are picking up back in Chapter 2, Part 2, and our next slide is an example problem where you're asked to find how long does it take sunlight to reach the Earth. So the items that you're given in this problem, or that you can look up, would be the speed of light, which is 3 times 10 to the 8 meters per second, and also the distance to the Earth, which would be 1.50 times 10 to the 8 kilometers. So we know our basic equation is speed equals distance over time, but now we want to solve it for time. So when we rearrange that equation, if we start off with our v equals distance over time, the easiest way to do it is multiply time by both sides. Therefore, time's going to cancel, and then you have TV equals D, and then you can divide out both sides by V, and that will give you the final equation of T equals D over V, as shown here. So what we're going to do is D is 1.5 times 10 to the 11th meters. Now notice how we have changed this distance from kilometers to meters, okay? And that is because our speed of light is meters per second. So let's do that conversion so y'all get to see it. So remember, you always write what you want to convert first. So we have 1.50 times 10 to the 8 kilometers, and then we look up on our conversion sheet and we say we have 1,000 meters is 1 kilometer. So our kilometers are going to cancel, and when we plug that in, we get 1.50 times 10 to the 11th meters. Okay, and that's where this value is coming from right here. Our speed is 3 times 10 to the 8 meters per second. So we just do that division, and our final answer comes out to be 500 seconds. Now your calculators might leave it in scientific notation, which is perfectly fine, or you take it out of scientific notation to get your 500 seconds. Okay, in this diagram, you're shown the time. It's just illustrating that example we just did, with the time being the 500 seconds, and then also the distance that you see. Okay, let's do another example. So in this one, you're asked for the average speed in miles per hour of the Earth revolving around the Sun. Okay, so you're looking at finding V. Okay, now we know that it takes 365 days for the Earth to go around the Sun. So what we want to do is convert that to hours. So we start off with our conversion, and let's just do that conversion so you see it. Now notice they do right here, we have 365 days, so that's what you want to convert. This is your conversion factor, 24 hours in a day. So your days are going to cancel, which will give you 8,760 hours. Okay, and now we're dealing with distance. Okay, we're given the Earth's radius, but remember our speed is distance over time. We can't plug the Earth's radius into distance, that D right there. We have to calculate distance. Now, the Earth is going around the Sun in a circular manner. So that's when the circumference of the circle would come into effect. So circumference is 2 pi r. So we're able to substitute this r value, the radius, for the Earth's radius. So therefore we have distance being 2 pi r, pi is 3.14, and then here's our radius of 9.30 times 10 to the 7 miles. So that is going to come out. Notice we have rearranged our equation. And actually, we haven't rearranged our equation. Sorry about that, because you're looking for speed. So speed's going to equal our distance, which is 2 times 3.14. So remember, that's pi. This is the radius, divided by 8,760 hours. So your final units are going to be miles per hour. And you can either put it in scientific notation or take it out. And you'll be able to tell on the exam because all the math are multiple choice. So if your answer choices are in scientific notation, you leave the answer in scientific notation. If it's not, then you would take it out. Okay, let's take a few minutes and do some additional practice problems, just to make sure everybody understands rearranging these equations. So our first one we want to do is you're asked for the average speed of a cruise ship that covers 370 kilometers in 24 hours. So let's start with our list. So we're looking for average speed. You're given the distance in the problem of 370 kilometers, and you're given a time of 24 hours. You're not told specifically what units your answer has to be, so therefore you don't need to convert anything. So we know our average speed is distance over time, so we have 370 kilometers divided by 24 hours, and that's going to give us an answer of 15.4 kilometers. Okay, let's do another one. In this one, we have a cheetah running at 1.5 miles. So our distance is going to be 1.5 miles. And our time is 2 minutes. And you're asked for average speed. Okay. And you're asked for average speed in miles per hour. Now you're going to have miles per minute. So let's go ahead and do that conversion right off the bat. So in 2 minutes, we know that in 1 hour, we have 60 minutes. And that is going to give us 0.03 hours. Okay, so now we can calculate the average speed being distance over time. We have 1.5 miles divided by 0.03 hours, and that's going to give us a final answer of 50 miles per hour. Okay. This one, if you can drive across Montana along Interstate 90 in 12 hours at an average speed of 95 kilometers per hour, how far is it across Montana? Okay, we start with our list, so we're looking for distance, how far. You're given a time of 12 hours, and you're given a average speed of 95 kilometers per hour. Now, do we need any conversion? No, because notice hours and hours would cancel. So you're looking for distance, which in this case is going to be kilometers. So we start off with our basic formula. Average speed is distance over time. We want to solve for distance, so in order to do that, we're going to multiply t by both sides. T is going to cancel, and therefore we're going to have distance equals t times v. So therefore our distance is going to equal 95 kilometers per hour times 12 hours. So the hours will cancel, and your final answer is going to be 1,140 kilometers. Okay, so in our next example problem we want to work on is, in this one, we're told that it's 4,470 kilometers between New York City and Los Angeles. If a cyclist can ride for 8 hours per day at an average speed of 25 kilometers per hour, how many days would it take him to make the ride? So in this one, you're looking for how many days. So you're looking for a time. Okay? You're given a total distance of 4,470 kilometers, and you're given an average speed of 25 kilometers per hour. So once again, we start with our basic formula, V equals D over T. We would multiply T by both sides. T cancels, therefore we have TV equals D, and then we divide both sides by V. V's are going to cancel on the left, so therefore you're going to have T equals D over V. Okay, so T is going to equal our distance of 4,470 kilometers over V, which is going to be 25 kilometers per hour. So your kilometers cancel, hours go up to the top. So you have 178.8 hours. But you're asked for how many days. So I need to convert these hours into days. And you're told that the cyclist is riding for 8 hours per day. So in one day, the cyclist rides 8 hours. Hours are going to cancel, so it will take him 22.4 days to complete the ride. Okay, this is going to end Chapter 2, Part 2.